climate technology encompasses innovations aimed at addressing environmental challenges. The key areas include carbon tracking for measuring emissions, renewable energy for sustainable power, environmental monitoring to assess natural conditions, and solutions for long-term sustainability. Understanding these fundamentals is essential for anyone entering the climate tech sector. Carbon tracking involves measuring and monitoring greenhouse gas emissions in real time. Accurate tracking enables organizations to report their carbon footprint reliably and helps develop strategies to reduce emissions. It includes identifying emission sources and using technologies to gather data efficiently. Renewable energy refers to power generated from natural sources that replenish themselves. Common types include solar power, which captures sunlight, wind energy, harnessing wind currents, hydropower from water flow, geothermal energy from Earth's heat, and bioenergy from organic materials. These energy forms reduce the reliance on fossil fuels and lower carbon emissions. Environmental monitoring is the systematic collection of data on air, water, and soil quality. Sensors measure pollutants and other key indicators such as particulate matter, carbon dioxide levels, pH balance, and nutrient content. Remote sensing technologies involving satellites and drones complement ground sensors to provide comprehensive environmental data. Sustainability solutions focus on reducing environmental impacts through efficient resource use and waste reduction. Strategies include improving energy efficiency, promoting recycling and waste management, conserving water, adopting green building designs, and implementing carbon offset programs. These approaches support long-term ecological balance. Calculating a carbon footprint involves quantifying the amount of carbon dioxide emitted due to consumption activities. A simple approach multiplies the energy consumed, measured in kilowatt-hours, by an emission factor representing the carbon intensity of the energy source. This calculation helps estimate the environmental impact in kilograms of carbon dioxide. Integrating renewable energy into existing power grids requires overcoming challenges related to variability and reliability. Key strategies include deploying energy storage systems, creating smart grids that manage supply and demand dynamically, and using demand response techniques to balance energy consumption. These efforts ensure consistent and efficient renewable energy usage. Environmental data analytics applies data science techniques to interpret environmental measurements. It supports climate modeling and forecasting to predict future conditions. Analytics also identifies pollution sources, optimizes resource use, and assesses risks to inform mitigation strategies. This data-driven approach enhances decision-making and policy planning. Government policies and regulations play a critical role in climate technology deployment. Important areas include carbon pricing mechanisms that assign costs to emissions, setting strict emission standards, providing incentives for renewable energy adoption, and enforcing compliance. Understanding the regulatory landscape is vital for aligning climate tech initiatives with legal requirements. The key components of climate technology include carbon tracking, renewable energy, environmental monitoring, and sustainability solutions. Gaining a solid grasp of these concepts prepares individuals to engage with technologies and strategies that drive climate action. Continued learning and exploration will deepen understanding and support effective contributions to this field.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.